All right, we're back. We've been working with object arrays, and in this one, we're going to be making a parking lot project. So as you can maybe see over here, I'm going to have a parking lot class, and then we have a parking space, but this is kind of the output of a parking lot. We see the initial parking lot is going to consist of 20 spaces with 4 rows, and I've got this thing going on. That's 4 rows. Notice that my rows are labeled and there are indicators for the parking spot. The parentheses here mean that it's an accessible spot for people with disabilities, whereas our brackets is for anybody. So the first 2 spots in each row are going to be accessible spots. What I do here on line 8 is I take my parking lot and tell it to occupy B03. And we see that now that particular spot has an X whenever I go to actually print it off, indicating that that spot is occupied. So we're going to be working on this project, and we're going to build it from the ground up, meaning this parking space class, that's what we're going to make, and that's what we're going to make today. So I'm going to go to File, New Project. I'm going to go Next, Next, and I'm going to change folders by selecting my AP Computer Science A, and I'm going to go ahead and make my parking lot subfolder. I'll hit finish. It's going to tell me it's going to create that. I'm actually going to do this in a new window so that I can take my code in, pull it to the side, so if I need to reference anything. So I'm going to expand my project folder, right click on the SRC, make a new Java class, which I'm calling parking space. So ultimately we're going to have an object array, and that array is going to be a parking space array. So this one class represents a single parking space. Think about the things that we're going to need, right? We're going to need labels. That is a kind of a combination of a letter, a character, and some numbers. More on that later. We're going to need to basically know, is the spot an accessible spot? We need to know, is the spot occupied or not? And so I'm going to use all of those things. These are the things you want to think about when you're first creating an object, a class that's used to represent an object. I'm going to create a string, which I'm going to call label. Now, you could use a char plus an integer, right? 2 separate instance variables, but I'm ultimately going to create a constructor that's able to handle that and combines that, concatenates it to a string. An example of this would be something like, B07. Next, I want basically some booleans, right? I want a boolean to tell me, is the spot occupied or not? And I want another boolean to tell me, is it accessible? Is the spot for people with disabilities? Okay, the moment that you have instance variables, you can start making your constructors, and fortunately with IntelliJ, we can auto-generate it by hitting Alt-Insert, and I'm going to create a constructor. It's going to ask me what instance variables I want to use in this, and I'm actually going to use all 3. So I'm going to highlight all 3 either by shift-clicking or control-clicking. And so we can make a parking spot by giving it a label indicating if it is occupied or if it's accessible. I want to give more functionality to my users by creating a parking space constructor that'll take in a character and a number. Now, something of note, and we'll work with this, but notice that even though the number is less than 10, I'm still using 2 digits, and we're going to basically apply that logic here. So I'm going to take in a char. You could easily take in a string, but I'm going to take in a char, which I'm going to call letter. I'm going to take in an integer, which I call num, and together those are going to ultimately be my label. We still need to take in a boolean to indicate if it is occupied and we need to take in a boolean to indicate if it is accessible. So I'm going to copy and paste those. Okay, these bad boys deserve some preconditions. Okay, for instance, right, our label needs to basically be in this format. So I'm going to precondition this. The whole point here is I'm not going to check for it, right? The label that's coming in, I'm assuming that it's in the correct format. Otherwise, I'm looking at, creating logic that is used to handle it. The precondition kind of takes care of that. It means it takes kind of the load off the programmer and makes it so that the user, whoever is ultimately using this class, is responsible for ensuring that they are in the correct format. So our precondition here is, you got to keep in mind, like, the precondition is just the way to go. A string can be any string of characters. There would be a lot of checking to ensure that it's in this format, when it's so much easier for me to just ask the user, hey, don't be silly. All right, so our precondition here is that label is in alphabetic character followed by 2 digits. Right, I can clearly say label here because the label is the parameter. We have labeled the label. It knows what variable name I'm talking about. Label is an alphabetic character followed by 2 digits. Okay, what that means out here for this constructor, in order for everything to jive correctly, right, we should precondition here. We should say that letter is alphabetic. Okay, why should I even say that? Well, this is a char. It's a single character, but it can be any character. That includes digits. That includes letters. That includes space. The new line character is technically a character. And so I'm assuming that it is alphabetic. So we got this precondition here saying that. I'm also going to have a precondition here that num is less than 100. Right? I'm not saying that a parking lot can't have a row with 100 or more spaces on it. I'm saying it's probably not a good idea. You should reevaluate your life. I'm going to limit this myself to say that it is less than 100. I should probably actually also go ahead and say that it is going to be greater than or equal to, well, greater than 0. I don't really want a spot labeled as 0. I guess you could. So I'm going to say that num is in this range so that we can easily follow this 2-digit scenario. However, I am going to have to apply some checks. Kind of. I'm going to modify this a little bit, because despite whatever I give the constructor as an argument, right? So if I type in 07 whenever I call this constructor, Java is going to get rid of that leading 0. Okay, so I'm going to have to put in some logic here to basically check to see if we need it and add it back to our string. We'll get there. Let's finish this out with our post condition, meaning if you follow the precondition, you should get this. Ooh, the alphabetic portion of label is capitalized. Okay, so this could be any character, lowercase or uppercase, and what I'm going to do here is in the constructor, just go ahead and modify it, make it capital so that we are consistent, and that actually adds flexibility back to the user. They can pass in lowercase or uppercase, doesn't matter, we're going to display it as uppercase. Okay, so effectively this boolean and this boolean, they're just going to be used to set these parameters. These other things I need to do some modifications to, right? I need to basically create that label. So why don't we create our string label? This is going to be a local variable, right? And I'm going to start off by saying it's this letter. Now, if I do this, right, we get an error because I am simply put trying to save a character into a string, and those aren't the same thing. I can force this to become a string by simply concatenating it with an empty string. Anytime you add a string to something else, Java is going to convert it to a string. So we're going to take this letter, convert it to a string. but I'm not actually modifying it. It's an empty string, and so it'll be the same letter it is, just as a string. Okay, so my letter is getting added, right? We're tacking on B as an example. I didn't need to check this number because if it's a number that's less than 10, it's a single digit, and I want to have that leading 0 so that long term my output is consistent. So what I'm going to do is check it. If num is less than 10, I know it's a single digit. What I'm going to do is take my label, that's this local variable, and I'm going to add simply a 0 to it. Okay, you have some options here as well. You could do the integer 0. Because I'm adding to a string, it's going to be treated as a string. You could explicitly say that this is a string. Doesn't matter. You could also say that it's a character. Java's going to end up converting it to a string no matter what you use, because we're ultimately saying label is equal to label plus 0. Right? And because label is a string, we have a string plus something, it's going to convert it to a string. So if my number is less than 10, it's a single digit, so I'm going to add a 0 to my label. Notice that label is a string, and so I don't have to worry about that leading 0 anymore. It's there. It's in the string. Finally, I'm going to add on my digit. So I'm going to take my label, and we'll add on that number. If the number is less than 10, right, I just added a 0, and then we're adding the number itself. If the number is 10 or greater, well, this 0 doesn't get added, so I'm just adding the number as is. So in the event that it's like 17, we would skip over this and just add it to our label. So at this point, my label is actually good. It's good to store in the instance variable, which I still need to do, right? I'm effectively going to do these things. I'm going to update these instance variables by giving them values. The occupied, it just goes straight in as it is. The accessible, it's going to go in just as it is. This label is going to be the label from here that I was ultimately kind of piecing together. Now, this says that the alphabetic portion of label is capitalized. I need to do that. So you could take the actual letter and try to capitalize that, right? If I took letter here and try to make it 2 uppercase, well, it's technically a character at that point. Character is a primitive data type. It actually doesn't have a method. So what I can make uppercase, what I can capitalize, is a string. And so it pretty much at any point, once your letter gets into the string, you could make it uppercase. That being said, like even though there's like a number in there, the uppercase won't affect the number. It's only going to ultimately affect the letter. I think probably a pretty simple spot to actually do it is right here. Right before we save it into the instance variable, let's make it uppercase. All right. Technically speaking, the label's not being modified. What's happening with the 2 uppercase method is that we're going to create an uppercase version of label, and that gets returned. So what I have highlighted is label as an uppercase version, but label itself, the implicit parameter, is not being modified. What I am saving into my instance variable is the uppercase version. So, yeah. I'm to a point where I kind of want to try this out. So I'm going to kind of whip up a quick toString just to see, is our parking space stuff working? So here's what I'm going to do. Maybe I should kind of document, what I want the format to kind of look like. It's not quite what our parking lot's going to look like, right? I just want this to be simple just for testing reasons. We're going to return a string representation of this parking space object representation of this parking space object in the format. Let's have like the parking space label, maybe And then maybe we'll do parentheses if it is an accessible spot, or if accessible, or we do something like A01 brackets if it's not. Okay, and then of course, maybe I should demonstrate another one, right? B99. This is going to be not accessible but occupied. Something like that. Okay. So we're going to need some logic, some if statements in order to differentiate between these two things, right? Occupied and accessible. Fortunately, those are booleans, so it's going to ultimately be clean. Our label is already ready to go at this point. So the only reason I'm going to create a string up front instead of doing everything at the point of return is because I need to add in that logic. I'm going to start by creating a string that I plan on returning. I'm just going to go ahead and add our label to that, right? It's already this. Now note that I want a space afterwards, so I'm going to tack on that space. I'm ready to go through some logic. I need to do parentheses if it's accessible. I need to do brackets if it's not accessible. How do I know? Well, we have this accessible boolean. I can simply use that here as my condition. If the spot is accessible, what I want to do is open up with a parenthesis. So I'm going to take my return string and I'm going to add a parenthesis. If it's not accessible, I'll hit this else, and we're going to add a bracket instead. Okay, so I have my opening depending on if it's accessible. I now need to check to see, is it occupied or not? If the spot is occupied, return is going to get an X. Otherwise, our return string is going to get a space. So I've handled the occupancy. I need to now deal with the closing parenthesis or bracket, depending on if it's accessible or not. If we're accessible, here, why don't we put it on our big boy pants? If it's accessible, closing parenthesis. If it's not accessible, closing bracket. So after we go through that gauntlet of logic, I'm going to return RTN. I'm ready to test this. So I'm going to right click on my SRC and do a new Java class, which I'm calling driver. We'll plug in a main method with PSVM. And I'm going to create a parking space object. Two different constructors I can go through, right? I can just give it the string label up front, which we do need to test this, so why don't we go ahead and do that? I will say something like A01 is our label, and let's do a true false. I'm going to ultimately go through basically every combination. Yeah, so let's print off space. I'm going to right click in free space and tell my program to run. We're ultimately testing the constructor. We're testing the toString by doing this. So our spot A01, that label looks good. Occupied, yep, we see the X. Is it accessible? False, we see the brackets. Okay. So my constructor looks good, the toString looks good for that particular test case. What I would do is continue testing, right? We have another constructor, so I'm going to create space 2. And let's use the other constructor, the one that takes in a character. How about B? And a number. And what I really want to test is single digits, right? Keep in mind that for this particular constructor, we added in logic that would handle the number if it is less than 10. And so that's what I want to test. So we're passing in a character, we're passing in a number. Let's also switch these up to test them, right? I'm literally going to invert them we're trying to test as much stuff as possible, kind of as concisely as possible. And here in this case, we have a B07. Okay. One thing I want to also test is, what if this number is 10 or greater? So I'm going to create a third space. And so, sure, we'll do a different letter. Sure, we'll do a different number. And let's switch these up yet again. There we see our letter of Z. 26, we clearly handled a number that was greater than 10. Occupied false, right? We got no X there. Accessible false, we got brackets. Okay. So this looks pretty good. Some final things that I would touch on. The first thing I'm going to show you and kind of talk about is this and this is effectively the same thing. We're setting instance variables. I'm going to show you something that's outside the subset. You don't have to know this, but I can basically, all we're doing here at the end is saving them into the instance variables. That's what this is doing, right? That these 3 lines of code, they're just saving values into the instance variables, which is basically what this constructor is doing. Okay, that is effectively duplicate code, and we don't generally like duplicate code. So what I can do instead is I can have this constructor call this one. Let me show you the syntax for that. I'm going to get rid of this stuff. And instead, what I'm going to do is call this. I want you to recognize that the syntax here is very similar to this dot notation, whereas this dot notation is allowing me to access an instance variable in this class. This allows me to call a constructor in this class. What I'm going to do is call this constructor. This constructor takes a string and 2 booleans. Okay, the string I want to give it is my label, right? I've pieced together this label. It does need to be capitalized, so I'm going to give it label.toUppercase. And then I need my 2 booleans, which I'm not modifying in any way, so I'm just going to pass those along. Oh, I don't like it. This needs to be the first thing, doesn't it? All right, we're scrapping it. The best thing I can do is, let's not scrap it. Here's what I'm going to do instead. I'm going to take this and this little section and turn it into a method. I obviously did not practice this part. So we'll do a private string. I'm going to do format label. We're going to take in a letter and an integer num. The problem with what I was doing is that that statement has to be the first statement in the actual constructor. So what I'm going to do is create this little helper method, and I'm going to take my information here. I'm going to send it here. It's effectively going to do this stuff. So I'm going to cut and paste that there. And then we're going to return our label, and let's go ahead and make it uppercase. Now what this allows me to do is to come back into my constructor. We're going to call the other constructor, but we're going to pass in whatever is returned by format label. Interesting that that is not. You're not going to let me do this either. Yikes. What I'm doing right now is called undoing it is performed by hitting Control Z if you're on a Windows machine. We'll just ignore that part happened. I'm going to leave it in because editing is hard. Last thing I am going to do is Alt Insert. You definitely want to do this. I want to get our getters and setters going. It's going to ask me what instance variables I want getters and setters for. I want all of them. So I'm going to either shift click or control click. All right, you could control click in order to get all three. And there we go. The only thing I'll kind of point out here is that whenever you use a Boolean, the syntax that people tend to go with, right, the convention people tend to go with, this is a getter. But the way it reads is occupied because you're only getting a true or false value back, right? So this is just a simple getter, but because it's a Boolean, we're following the typical convention, which is using is as opposed to get. Okay. We're going to pause there, and I will see you in the next one where we will continue with our parking lot project.